This is Physical Chemistry, Part 2, Chemical Kinetics, Chapter 35, Elementary Chemical Kinetics, Section 35.1, Introduction to Kinetics. Chemical kinetics studies the rates and mechanisms of chemical reactions. The reaction rate tells us how fast the reaction proceeds. The mechanism tells us what elementary reactions are involved. For example, this reaction, the combustion of methane in oxygen, produces CO2 and water. This is a very complex chemical mechanism consisting of many elementary steps. How do we define the reaction rate of this reaction? Usually we look at the products. We look at how fast this CO2 is being produced. So for example, over here, the reaction rate can be defined as how fast the concentration of CO2 changes with time. Also, we can use water to define the reaction rate. Over here, this is how fast the concentration of water changes with time. But if you look at this balanced chemical reaction, whenever one CO2 is produced, two water molecules are produced at the same time. Therefore, we need to include this 1/2 in front of d water over d time. We can also use reactants. Over here, this is how fast CH4 is consumed. And over here, this is how fast oxygen is consumed. But again, whenever one CH4 is consumed, at the same time, two molecular oxygen are also consumed. Therefore, you have 1/2 in front of the CO2 over dt. And also pay attention to the negative signs. This is because, again, methane and oxygen are consumed, so this derivative is negative. Now let's look at these molecules. CH4, O2, CO2, water. In this reaction, well, it seems we need to break this double bond. We need to break this double bond. We need to break all 4 CH bonds. And then we have to form 2 CO double bonds and 4 OH single bonds. You can't just break this 6 bonds at the same time and then form this 6 new bonds. So this chemical reaction has to be a very complex mechanism. Now I'm going to show you the elementary reaction steps involved in this mechanism. Initiation. Again, we have 2 reactants, CH4 and O2. And then you ignite the mixture of this methane and O2. This is what happens at first. After ignition, one CH bond is broken. And then the OO double bond can also be broken. Now you have radicals, H radical, CH3 methyl radical, and oxygen radical. All right? So in this initiation step, radicals are produced. Radicals are species with unpaired electrons. Radicals are typically highly reactive. Now let's look at this H radical. This H radical, again, it's very reactive. It attacks a molecular oxygen to form 2 new radicals, hydroxyl and oxygen radicals. This is called a branching reaction because in this reaction, more radicals are generated. You started from this H radical. You end up with 2 radicals, 2 different radicals, hydroxyl radical and oxygen radical. And then propagation. Usually in a propagation reaction, radicals appear on both sides of the equation. And usually you have only one radical on the left-hand side and one radical on the right-hand side. you just get different radicals. For example, this H radical may attack one of these 4 hydrogen atoms in methane to form H2. And this methane loses one hydrogen and form this CH3 radical. And also over here we have hydroxyl radical. It can also attack methane to form water and another methyl radical. So now you see one of the two products. The other product is CO2. How is CO2 being formed? Well, we'll have to look at many more elementary reactions. You can see even formaldehyde is generated, the CHO dot radical is generated, and carbon monoxide is one of the products in this many elementary steps. So finally, this carbon monoxide reacts with this highly reactive hydroxyl radical to produce CO2 and this hydrogen radical. So this is how CO2 is produced in the mechanism. And the reaction rate is defined to be this dCO2 over dt. How the concentration of CO2 changes with time. And therefore, we focus on this single elementary reaction and realize that we have one CO and one hydroxyl on the left-hand side. They are the reactants. And because this is an elementary reaction, the reaction rate is simply K times the concentration of CO times the concentration of hydroxyl. This is a second-order elementary reaction over here. It's first order with respect to CO, also first order with respect to HO. Overall, it's second order. And this is how fast CO2 is produced. So you can see there are so many radicals. Eventually, the radicals will be annihilated. For example, any radical may react with a hydrogen radical. This is because usually we have a higher concentration of hydrogen radical than many other radicals. And then these two can form a bond, a single bond, and you get RH. However, in this reaction, between H radical and R radical, it's exothermic. A lot of heat is released to what? To a surrounding molecule or to the surface of the container, the reaction container. So this M stands for medium or media. This is just any other molecules that can take away the heat or the energy released from the formation of this RH bond. And M star means energized M.